sklearnutilsgenbatches. Description: the genbatches function from scikit-learn's utils module is a utility for efficiently generating batches of data. It's particularly useful when working with large datasets that cannot fit entirely in memory. This function helps to split the data into manageable chunks, allowing for processing in batches without overwhelming system resources. Inputs: n samples. This input specifies the total number of samples in your dataset. It's a positive integer indicating the size of the complete dataset. Batch size: this input defines the desired size of each batch. It's a positive integer representing the number of samples to include in each batch. N batches: this input is optional. If provided, it sets the exact number of batches to generate. If not provided, the function automatically calculates the number of batches based on n samples and batch size, ensuring that all samples are included. Outputs: a generator object. This object yields batches of indices. Each batch is represented as a slice object, indicating the starting and ending indices for the current batch within the dataset. This allows you to easily access the corresponding data for processing. Steps: calculate the number of batches. The function determines the number of batches needed to cover all samples. If n batches is provided, it's used directly. Otherwise, it's calculated by dividing n samples by batch size and rounding up to ensure all samples are included. Generate batch indices. The function iterates through the calculated number of batches. In each iteration, it creates a slice object defining the start and end indices for the current batch. The start index is calculated by multiplying the batch index with batch size. The end index is calculated by adding batch size to the start index. The slice object is then yielded to the caller. Metrics: none. The function itself doesn't directly provide any metrics, as it's primarily focused on generating batches. Metrics would typically be calculated during the data processing steps that use these batches. Visualization plots: none. The function doesn't generate any visualizations directly. Data processing steps that utilize the generated batches might involve visualizations. Fine-tune parameters: batch size. Adjusting this parameter allows you to control the size of each batch, enabling you to balance memory usage and processing efficiency based on your computational resources. Smaller batches consume less memory but might require more iterations, while larger batches consume more memory but reduce the number of iterations. N batches. Specifying this parameter allows you to control the precise number of batches to generate. This can be useful if you have specific requirements regarding the number of batches or if you want to ensure consistent batch sizes. Uncertainty methods: none. The function does not involve any uncertainty estimations or methods. Challenges and fixes: Challenge 1: insufficient memory for large datasets. Sample use case: when working with extremely large datasets that cannot be loaded into memory entirely, processing in batches is essential. However, if the batch size is too large, it can still lead to memory issues. Fixes: reduce the batch size, decrease the number of samples per batch to minimize memory consumption. This might increase the number of iterations but can prevent memory overflows. Utilize memory-efficient data structures. Employ data structures like NumPy arrays or sparse matrices, which are designed to efficiently store and manipulate large amounts of data in memory. Employ techniques like data sharding or distributed processing. Split the dataset across multiple machines or processes, allowing each to handle a subset of the data and reducing memory pressure on any single machine. Challenge 2: uneven distribution of samples in the final batch. Sample use case when n samples is not perfectly divisible by batch size. The last batch might contain fewer samples than the rest. This can lead to inconsistencies in processing if the final batch is treated differently. Fixes: pad the data, add dummy samples to the dataset to make n samples perfectly divisible by batch size. Ensuring consistent batch sizes. Handle the final batch separately. Implement specific logic to handle the final batch differently, accounting for its potentially smaller size. Use a different batching approach. Explore alternative batching techniques, such as random sampling or dynamic batch sizing, which might address this uneven distribution issue.